Okay, in this video we're going to go ahead and take a look at the different problem types that appear on your Math 101 Test 3 review. First we'll start with question 4. Question 4, we're asked to determine whether the given ordered pairs are solutions to the equation 2x minus 3y equals negative 24. And we're asked to also show our work. I'm only going to show you one of these. You've got a couple other ones, but I'll show you how to do this first one here. So all I need to do is plug the value for my ordered pair. Remember, an ordered pair is x first, y second. So I'm just going to plug that ordered pair into this equation up here and see if I get a true statement. So, okay, so I'm going to put a 0 in for x and then a 6 in for y. So here's what that would look like. 2 times 0 minus 3 times 6 equals negative 24. Let's take a look. So 2 times 0 is going to give me 0, and then negative 3 times positive 6 is going to give me a negative 18. And so I'm left with a statement, negative 24 equals negative 18. That's not a true statement, so I would say that no, it is not a solution. Next question we'll take a look at is 5. Find the slope and the y-intercept. And we want to write this y-intercept as an ordered pair of the line 2x minus 8y minus 12 equals 0. Well, notice we're looking for the slope here and the y-intercept. So anytime we're looking for the slope and y-intercept, we're going to want to use or organize our equation in the slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is our y-intercept. So if I can get this equation organized like this, I'll know the slope and the y-intercept. So let's see, I'm trying to solve for y or get y all by itself. So the first thing I would do is undo any addition or subtraction. So I have to do a couple things here. I need to get rid of this 2x. So to get rid of that 2x, I would subtract it. So I'll subtract 2x from each side. Then I would have this negative 8y minus 12 equals negative 2x. Not 28. Equals negative 2x. Okay? Still continuing to undo addition or subtraction, I would want to add 12 to both sides. So then I have negative 8y equals negative 2x plus 12. Okay? One last thing, now I'm trying to get y all by itself, so I would divide by 8. In this case, sorry, negative 8. So divide everything by negative 8. And I want to divide each of these terms then. Okay, so then I have y equals, let's simplify that negative 2/8. That fraction negative 2/8 could be simplified to a positive 1/4. So that would be positive 1/4 x. And then this 12 divided by negative 8, well, that's going to give us a negative answer. Let's work on that. That needs to be written kind of as a mixed number here, since we're going to try to identify this y-intercept. So let's see, 8 would go into 12 one time, and it would have 4 left over. So we'd be looking at 1 and 4/8. And then we're going to want to simplify that 1 and 4/8. So let's see. 1/4 x minus, that 1 and 4/8 is just a half, so minus 1 1/2. Okay? Now we've got it in the slope-intercept form. Now I want to identify the slope and identify the y-intercept now as an ordered pair. So the slope, we use m for that, is just a positive 1/4. And my y-intercept is negative 1 1/2, but I want to write that as an ordered pair. So remember, when the y-intercept occurs, our x value is 0. So I put a 0 in for x and this negative 1 1/2 for the actual place this thing crosses the y-axis. Now we'll take a look at question 7. Find the slope of the line that passes through these 2 points. Obviously, when we're talking about slope, we don't want to have any decimal answers, and we're asked to show our work. Okay, so remember, the slope is just the change in y over the change in x. So all we have to do here is figure out how much y is changing between these points and then how much x is changing. Doesn't matter which point we choose as our first one, as long as we're consistent. So I will look at this point first, and then we're changing at this point second, since that's the way they're listed. So let's start with the change in y. We're starting at 10 and going to 2. So we're starting at a larger number and moving to a smaller number. That is definitely going to be a negative movement. So if we start at 10 and end up at 2, that is a negative 8. That's a movement of kind of negative 8 when we think about the change from positive 10 to positive 2. Okay, now let's take a look at our x value. We're starting at 4 and moving to negative 4. Again, this is a negative movement. We're starting at positive 4, moving to negative 4. If I was looking at the number line here, here's 0, here's positive 4, here's negative 4. If I was to make this change, I would actually be moving a negative 8 again. First 4 units, negative 4 units to get to 0, and then another negative 4 units to get to negative 4. So that is a movement of negative 8 again. And so the slope of this line is actually negative 8 divided by negative 8 is positive 1. So the slope of this line is just positive 1. So I would say, okay, well, the slope of this line is positive 1. Okay, next question we'll look at is 9. Write the equation of the horizontal line that passes through this point, negative 4, 5. So if I was just kind of sketching this graph, this point, negative 4, 5. So 1, 2, 3, 4, and then positive 5. 1, 2, 3, 4, 5. So it's going through this point right there, negative 4, 5. And we want this thing to be a, whoops. Anyway, you get the idea. We want this thing to be a horizontal line. So we want this line kind of going like this. Well, remember, horizontal lines, these are the values where y is equal to some number c. Because basically what happens here is we end up with the same repeating y value all the time. If we look at these points on this line right here, they kind of keep ending up in this same horizontal position. So that means y is just going to be equal to some number. So let's look at this value. It's passing through this point, negative 4, 5. The y value of that point is 5. And in fact, the y value of all of these points on this horizontal line is 5. So that is the equation of our line, is just y is equal to 5. Okay, question 11, we're asked to graph the following equation. And you'll notice this equation is in slope-intercept form. There's slope-intercept form. The number that's in front of x is going to be our slope. The number that we're adding or subtracting on the end is going to be our y-intercept. So if I want to graph this, I'll first start with the y-intercept, the point, and that is the point where this equation here is going to cross the y-axis, and you'll notice the y-intercept of our equation here is just positive 3. So I'd come up 1, 2, 3. There's the point where this line is going to cross the y-axis. Now I'm just going to use the slope, and the slope of this line is 1/5. Remember, slope is change in y over change in x. And so a slope of 1/5, starting from this y-intercept that I've already plotted here, my change in y would be 1, up 1, over 5. 1, 2, 4, 5. There'd be the next point on my line, so I can go ahead and graph this. Okay, next question we'll take a look at is question 15. We're asked to graph this. Now notice this is standard form. Standard form is, you know, some number times x, some number times y is equal to some number. And usually when we're in standard form, the easiest way to graph this is by using the intercepts. So, let's make a little t-table here. And so the x-intercept will occur when y is 0, and then the y-intercept will occur when x is 0. So really we're just kind of graphing these zeros or finding these zeros. So if I put a 0 in for y, plug in a 0 into y for this equation, essentially that 4y term is going to drop out. I'll show you what I mean here. So I have negative 3x plus 4 times 0 equals negative 12. So this 4 times 0, of course, is just 0. That term's going to drop out, and then we're left with this little simple equation, negative 3x equals negative 12. Well, the solution to that is just going to be positive 4. Now let's go ahead and do the same thing for finding my y-intercept, where x is 0. Well, if we plug x up in here, negative 3 times 0 is going to be 0. That term is essentially going to drop out, and I'm left with this equation. 4y is equal to negative 12. Well, the y value that I would need there would just be negative 3. Now I have 2 points for this equation. Now I can go ahead and graph this line. So I'd say over 4 up 0. There's my x-intercept, and my y-intercept is over 0, neither moving left nor right, down 3. 1, 2, 3. There's my y-intercept. So I'll just go ahead and graph these and connect them. So anytime an equation is in this standard form like this, something x, something y equals some number, I think the easiest way to graph that is just go ahead and find the two intercepts and connect them. Okay? Question 17, we're asked to graph now this linear inequality. Well, the first thing we need to do is find some points on this thing like as if it was an equality or we had an equal sign in it. So this is where we're going to find our points. This y equals negative 2/3 x plus 4. You'll notice this is in slope-intercept form. Y equals mx plus b. So I know the y-intercept and I know the slope. So my y-intercept is 4. 1, 2, 3, 4. And I know I have the slope of negative 2/3, which means change in y is negative 2, change in x is 3. So I'd go down 2, 1, 1, 2, and then to the right 3. 1, 2, 3. So those points are going to be the points on my line. Now, however, I don't want to connect those points just yet because I want to check to see if I have a solid or dashed line. And you'll notice in my inequality now, it's a strictly greater than symbol, which means the line is not going to be part of the solution. So I'm going to go ahead and make this a dashed line here. Okay, that's the way I communicate the line is not part of the solution set. Now I need to either shade the top right of this graph or the lower left of this graph. I just need to use a test point to figure that out. Typically we use 0, 0 if it's not on the line. If 0, 0 was on the line, I wouldn't be able to use it. But in this case, 0, 0 is not on the line, so let's go ahead and test that point, 0, 0. So all that means is I'm going to plug 0, 0 into my inequality and see if I get a true or false statement. So let's see, if I plugged 0 in there, I'd get this. 0 is greater than negative 2/3 times 0 plus 4. And so you can see the negative 2/3 times 0 just dropping out there for us. And so I'd be left with this statement. 0 is greater than 4. That is not a true statement. So that tells me this point 0, 0 is not a solution to this inequality. That means none of the points on this lower left side are going to be a solution to this inequality. Therefore, all of the solutions have to be on the other side of this line, up here. So here's where I would want to shade to indicate that all the solutions are going to happen up here. Take a look at question 19. Graph the line that passes through the points, or I guess these are A and B points, the point 5, 6 and 8, 2. Write the equation of the line that goes through the point 0, 6 and is parallel to the graphed line. Okay, lots of stuff going on here. First thing we want to do is go ahead and graph this line. So we're looking at the point 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, there's one of my points, the point 5, 6, and then the point 8, 2. Ooh, 8, 2 is going to go off of this graph. So what that tells me is I don't want to count by 1s when I'm making this graph. I want to count by 2s. So let's go ahead and erase this point. And let's say, okay, now we want the point 5, 6. So here's 2, 4, 6. So the point 5 is going to be halfway in between there. So 5 is right halfway between there, and then I want to go up 6. So 2, 4, 6. So my point is right there. Okay, let's erase that other stuff on there. So here was my point. Okay, and then the other point is going to be 8, 2. And again, I'm counting by 2. So I'd say 2, 4, 6, 8, and then up 2 would be right here. Okay, I've got these two points. Now let's go ahead and graph this line. All right. Now I want to write the equation of the line that goes through the point 0, 6 and is parallel to this graphed line. So the point 0, 6, 0 in the x direction, but then I want to go up 6. So 2, 4, 6. So there's the other point of my graph line there. And again, I'll get rid of some of this stuff here. So now I want to write the equation of the line that's parallel to this one that I've already got graphed going through this point 0, 6. So if these lines are going to be parallel, these lines have to have the same slope, which means the slope of my new line has to have the slope of the original line, which was going through these points. So let's find the slope of the original line, and so we'll call that original line M1, the slope of that sucker. So let's see, change in y, starting at 6, going to 2, that is a change of -4. Change in x, starting at 5, ending up at 8, that's a change of +3. So the slope of this original line is -4/3. That means the slope of my new line has to also be -4/3, since these lines are parallel. Alright, so I have the slope. Now the only other thing I need is a point to find this line. And you'll notice we've got this point 0, 6. I could use point slope at this point to find the equation of the line, but also notice here that this point is 0, 6. This is the y-intercept. This is actually the y-intercept right here. And so remember we use b for the y-intercept. That's the y-intercept. So you'll notice I have a slope and I have a y-intercept. I can go ahead and use slope-intercept form to write the equation of this line. So I would say, remember slope-intercept form, y equals mx plus b. So I'm just going to plug this in. Y equals my slope then is -4/3 x, and my y-intercept is just 6. So I'd have +6 there on the end. And there's the equation of my new line that is parallel to the original, passing through this point 0, 6. Okay, question 21. Given the points 8, 5 and 10, 2, write an equation of the line. Write an equation of the line that goes through these points, basically. And we want to write this equation in slope-intercept form. All right, so if we want to write this thing in slope-intercept form, we need two pieces of information. We need the slope, and we need the y-intercept. Let's start with the slope. We can go ahead and find the slope here. Remember, slope is change in y over change in x. All right, so if we start at 5, end up at 2, that's starting at 5, moving to a smaller number, so that's a negative movement, and that's a change of -3 for the y. And let's take a look at 8. 8 to 10, so for my x, that's starting at 8, moving to 10, that's a positive direction. So that's a change of 2. So I have the slope of this new line. The only other thing I need to have here is a y-intercept. But you'll notice I don't have a y-intercept, because the only time I have a y-intercept is if I have this, a 0 in the x position, and then whatever number is over here in the second one, that would be my y-intercept. But notice none of these points have a 0 in the x, and use the x coordinate. So I can't use slope-intercept form to find the equation of this line. What I am going to have to use is point slope. Remember, we use point slope when we don't have a y-intercept, but we know a point. And so we can choose either one of these points when I write the point slope form of this equation. These numbers here seem smaller, so I'll go ahead and just use that one, 8, 5. You could use either one, it wouldn't make a difference. And so remember, here is point slope. Y minus y1 equals m, our slope, times the quantity x minus x of 1. And here, remember, our point values. So I'm going to use this point 8, 5 up here and plug that in. So then I would say y minus my y value, which would have been 5 there, equals my slope, which was -3/2, times x, and then minus my x value at that point, which was 8. Okay? What I need to do now, it's in point slope form, what I need to do now is get it over here and make it look like this. Get it in slope-intercept form. Once I get it into slope-intercept form, I'll know, actually I've answered the question. We wanted to write an equation in slope-intercept form. So let's see. I would start by distributing this -3/2 to each of these numbers. Let's see. Y minus 5. -3/2 times x, we'll just leave that as -3/2 x. Now, -3/2 times 8, that common factor, let's come over here with scratch work. So it's negative times a negative, it's going to be a positive. So now I'll just worry about what's going to happen when I multiply. So I have 3/2 times 8 over 1 there, basically. And you'll notice a common factor of 2 is going to divide out here and here, which will leave us with a 4 up top. So 4 times 3 are 12. That's what I'm getting there for that value. I'm almost to this slope-intercept form. I just got to get rid of this minus 5 here. So I would add 5 to each side. And so then I have y equals negative 3 halves x plus 17. And so there is my equation now written in slope-intercept form. Okay, last question we'll take a look at is question 23. Do not graph the answer to the following. Describe how the two lines are related, parallel, perpendicular, or neither, and then we want to support our answer mathematically. Well, parallel and perpendicular lines, remember their relationship is involved in their slope. Parallel lines have the same slope, perpendicular lines have the opposite reciprocal slope. As they stand right now, these equations are not organized so we can look at these equations and figure out what the slope is. Probably what we want to do now is organize these equations so that they're in slope-intercept form, y equals mx plus b. Let's take a look now and reorganize these things. I'll move this one over here, and we'll work on this 2x plus 3y equals negative 12. Then we'll come over and work on this one. Okay, so 2x plus 3y equals 12. The first thing I would want to do then is minus 2x from each side. Okay, so then I have 3y is equal to negative 2x minus 12. Now I need to undo this multiplication, divide by 3, and then I make sure I divide both of these terms by 3. So then I have negative 2/3 x, and then minus a 4 when I do that division. Okay, let's take a look at this other equation. Again, I want to get y all alone, so I would add 6x. So I have 9y equals 6x plus 4. That was a positive 4, so I would want to write plus 4 in front of it. Now I'll divide by 9. Every one of these terms. And so let's see, I'm simplifying that 6/9. There's a common factor of 3 in each of those. So that would be 2/3 x. And then 4 divided by 9, that's not going to be even. There's no common factor, so that's just 4/9 as a y-intercept. But that's okay. Really what we're looking for here is to compare the slopes of these lines. And so the slope of my first line was negative 2/3. The slope of my second line was positive 2/3. So if those slopes were the same, these lines would be parallel. If those slopes were opposite reciprocals of one another, they would be perpendicular. But in this case, they're neither of those things, so these lines aren't perpendicular or parallel. So we would say neither slopes are not the same, nor opposite reciprocals.